Students, in this video we are going to learn the basic concept about the process of diffusion. Diffusion. See, first of all, the statement of diffusion. The process of spreading of molecules from one place to another place. The process of spreading of molecules from one place to another place is called diffusion. The word diffusion came from a Latin name diffusa. The meaning of diffusa is spreading, moving from one place to another place. In their view, that it means in the name of the Latin, there is a migration is there from one place to another place. The migration of the people, migration of the birds, migration of certain races from one area to another area. For that purpose, they used the word diffusa. The word diffusa means migration, movement from one place to another place. For that purpose, we may have different kinds of activities. Now, we are going to study the properties of process of diffusion in the solids with an activity. For that activity, we require a round bottomed flask, water is required, potassium permanganate is required. Instead of this potassium permanganate KMnO4, we can use copper sulfate. If the copper sulfate is not there, we can use simply ink also. Whatever it may be, we can use and we can study the properties of diffusion in solids. Let us do that activity now. To do this activity, I am going to take some water in a round bottomed flask. I will pour the water up to the neck of the round bottomed flask. Now, you already know this is called as a spatula. By using the spatula, transfer some amount of the potassium permanganate into the water. Some quantity of the potassium permanganate into the water. Carefully, how the potassium permanganate color is diffuses. See here, we can understand how the color of the potassium permanganate is diffusing. See how beautifully it is moving from top to bottom. You can understand clearly, means there is a movement of the molecules of the potassium permanganate from top to bottom. This is simply we can understand the process of diffusion. Even inside of the water also we can understand the procedure or otherwise movement of the potassium permanganate color, which is violet in color, purple in a dark color, it is moving. What does it mean? There is a process of movement of the potassium permanganate solid into the liquid. This means we can understand the movement of or otherwise the diffusion of potassium permanganate, that is nothing but solid into the liquid. Let us see the diffusion in gases. For that example purpose, any one of your friend applied a perfume. Whenever he used to sit in the corner of the room, throughout the room, after certain time, we are going to take that smell. Whatever it may be the kind of the smell, we are going to observe different kinds of the smells from the classroom. Right. To do that activity, we required a small thing. For example, you have an agarbatti is there with you. You already know agarbattis. Right. Ask your friend to stand at the room at one corner of the room with an agarbatti. Means don't treat it that agarbatti, that person should stand at one of the corner. Can you inhale the smell? The answer will be no. We can't inhale the smell. Lit the agarbatti. After certain time, you can smell the agarbatti. or otherwise dhoop stick, or otherwise incense stick. All the words are same. How this is possible? If you observe, if this is the incense stick, the fumes that is coming from the incense stick will mixes with the particles of air and they spread from one place, that is one corner to the another corner. What does it mean? There is a spreading of air molecules from one place to another. This is nothing but the process of diffusion in the gases. Why? Because here the smoke that is coming from the incense stick is mixes with the air and is moving from one place to another. This kind of example we can see even in our houses, temples, in some different kinds of the areas. For example, we are going on a road, a bad smell is coming. How can you inhale that smell, or how can you say it is bad smell? The smell that is released from that particular place is spreaded from one place to another place. Means the smell or otherwise aroma. Aroma means sweet smell. Whenever you are going on the road somewhere else, they are preparing delicious biryani or something. We are going to take the smell in a particular manner. That is the process of diffusion only. Why? Because that smell particles are mixed with the air molecules and they are spreading from one place to another place. So we can say that there is a diffusion in the case of gases. We should remember one thing, students. Rate of diffusion of gases is greater than the rate of diffusion of liquids. Rate of diffusion of liquids is greater than the rate of diffusion of solids. That means the process of diffusion is very, very high in the case of gases, next in the case of liquids, next in the case of solids. Now, let us come to know what are the different examples and what are the different uses of the diffusion now. See now, certain gases like oxygen, carbon dioxide diffuse into water. Diffuse means they are mixed with the water to support the aquatic life. What is the explanation for this? For example, whenever there is a fall of rain, then oxygen is mixed with the water and is dissolved in the water. That oxygen is taken by the aquatic animals like fishes and aquatic plants. For that sake only they are going to sustain their life. Again they will release the carbon dioxide. That carbon dioxide also released into the water. One more example we can see. We are going to drink aerated cool drinks. Aerated cool drinks. What is that aerated cool drink? That is nothing but a drink which is mixed with the carbon dioxide. Whenever you open Sprite or Thumbs Up or something, whatever it may be, that machine should be aerated. So they consist of carbon dioxide. The liquid that present inside that bottle is mixed with the carbon dioxide. Whenever you open with the cap, then the carbon dioxide will be eliminated. Those such kind of the drinks are nothing but aerated cool drinks or aerated water. In this example, we can understand that carbon dioxide is mixed with the liquid and at the same time oxygen is also mixed with the liquid. Sometimes, if the oxygen percentage in the water is gradually decreasing, then what happens to the aquatic life? They try to come to the surface of the water. If you see a big blue whale, oxygen that present in the water is not sufficient to breathe to it. For that sake, every time the blue whale comes to the surface of air, then automatically it is going to take more amount of the oxygen through its mouth. For that sake, we can see the flips of blue whale in the sea. Sometimes dolphins also will jump like that only. Why? Because oxygen that present in the water is not sufficient into their lungs. Next, come to the second example. oxygen diffuse into the blood from the lungs. We already know the end part of the lungs is called alveoli. Alveoli is joined with the blood vessels. Then there is a transport of oxygen from alveoli to the blood. We already know that in the process of respiration. One comes to the third one. Carbon dioxide diffuse from the blood to the lungs. Yeah, in the process of respiration only, carbon dioxide again enter into the blood. Come to the fourth one. Tea bag placed in a cup of hot water. A tea bag is there that placed in a cup of hot water. We are going to see whenever you went to a railway station, they will give you a sachet of tea bag. Then we are going to put that tea bag in the hot water or otherwise the hot milk. Of course, they will say hot milk only, but little amount of the water, more amount of the water is there in that. Though you put the hot bag into that milk, then automatically what happen? The essence that present in the tea bag is diffuses into the hot milk and mixes with the hot milk. Instantaneously we are going to prepare the tea or otherwise coffee. Generally it is possible along with the tea molecules only. Why? Because the particles of the tea molecules are big when compared to the coffee molecules. Now comes to the fifth one, aroma. Aroma means sweet nature of the food. That's what we already said. If inside our house or otherwise somebody's house, if they are making any delicious food, then our mouth will get water. That means it becomes watery because of the smell, the good smell that is coming from the food. For that second, that is called aroma. Generally, it will be taken place in the case of while cooking chicken, biryani, like such kind of the things. Right. Then come to the next one. Bad smell of gas. Bad smell of the gas. For example, say inside the kitchen, the gas is leaked. Then automatically a mother is used to scold us. Hey, see, once go and see there, the gas is releasing or something. This means the bad smell of the gas from the kitchen diffuse into the air and reaches us. So, such kind of the examples are there in the case of diffusion. Now, let us try to understand the process of diffusion in the case of gases with an activity. From that activity, what we are going to learn is rate of diffusion of a gas depends on its molecular weight. Let us see the activity and then we will come to the conclusion. See students, to do this activity, we have hydrochloric acid HCl bottle is there with us and ammonia solution is there with us. Ammonia solution is there with us. Ammonia is nothing but ammonium hydroxide, NH4OH. Right? I am going to take a little quantity of HCl in a china dish. A little quantity is enough for us. Then we should be very precautious while taking. And again, I am going to take some amount of the liquid ammonia in another crucible. So here we can say that in one of the liquid what is there? Hydrochloric acid is there. And another liquid ammonium hydroxide is there. We should be very cautious while doing the activity. Right? Now, I already kept a stand and as well as a test tube is there into that. I already fixed that one. See, with the help of tongs, I am going to soak some amount of the cotton into the hydrochloric acid. Soak some amount of the cotton into the hydrochloric acid. After soaking clearly, drop it into the test tube. I am going to drop that into the test tube. Yes, you can understand, you can observe it clearly. See that it should be there at the bottom. What I did? I dropped the cotton plug which is soaked in the hydrochloric acid to the bottom of the test tube. Now, take one more ball of cotton and soak it in ammonia solution. We are going to soak that one in the ammonia solution. right? Now, after soaking it into the ammonium hydroxide solution in a clear manner, put this one at the top end of the. Now we can observe here some white fumes are formed, and again place a rubber cork. We can observe inside a white fumes are there. If you observe the density of the white fumes, of course, throughout the beaker, throughout the glass tube, we can observe a white fumes, but more amount of the white fumes are nearer to the HCl. You observe here, more amount of the dense fumes are there nearer to the HCl. Those fumes are not there nearer to the cotton plug which is soaked in the ammonium, but those more amount of the fumes are there, more amount of the white dense fumes are there nearer to the HCl. What the reason for this? What the chemical reaction is happened in the test tube, that I will explain on the board right now. In this activity, what we used is, we used a glass tube which have opened on both sides. In one of the side, we soaked a cotton plug in HCl. The molecular weight of hydrochloric acid is 36.5 AMUs. Whereas at the other end, we dipped a cotton plug in liquid ammonia solution, NH3, liquid ammonia, whose molecular weight is 17. Then both the ends are closed with rubber caps. Now what happens? The fumes are started from HCl, and at the same time some of the fumes are started from liquid ammonia. But why we observed the white colored fumes nearer to the cotton plug which is soaked in HCl? For that reason is, the rate of diffusion of HCl is less when compared to rate of diffusion of ammonia, because HCl has a molecular weight of 36.5, the molecular weight of ammonia is 17. Because of the less molecular weight, ammonia solution means the fumes that is coming from the cotton plug which is soaked in ammonia diffuses rapidly when compared to rate of diffusion of HCl. Then what happens? The fumes of hydrochloric acid, HCl, which is a gas, is mixed with the fumes of liquid ammonia to form ammonium chloride, which is a gas and which is there in the form of white fumes. From this, what we can understand? Because of highest molecular weight, the rate of diffusion of HCl is less when compared to the rate of diffusion of ammonia, whose molecular weight is 17. From this, what we can conclude is, rate of diffusion of a gas depends on its molecular weight. Not only this, you may have bromine. Generally the bromine is in red color. If you throw the bromine into the space, we can observe the spreading of bromine gas into the space. Why? Because its molecular weight, and it has a rapid process of expansion will be there. From this activity, we proved that rate of diffusion of different gases depends on its molecular weight. Depending upon this reason only, hydrogen gas is used in the hot air balloons. Why? Because molecular weight of hydrogen is very less when compared to the remaining other gases. Because the molecular weight of hydrogen is only 2 units. And when compared to the carbon dioxide, for example, take a balloon and blow air into it by using our mouth, then what happens? Is the balloon will goes up? No, the balloon does not rises up. the balloon again comes to ground because inside carbon dioxide is there. Why? Because you blowed air outside, that means inside the balloon carbon dioxide is there. Molecular weight of the carbon dioxide is more, that is 44 units. Because of the more weight, that is 44 units, it always try to comes towards the ground only. Same kind of the balloon which is filled with hydrogen moves in the upward direction, whereas well as the balloon which is filled with carbon dioxide moves in the downward direction because of heavy weight. From this video, from these activities, we can understand the process of diffusion depends on its intermolecular space and as well as molecular weight. See, rate of diffusion of solids is very less when compared to rate of diffusion of liquids, is less when compared to rate of diffusion of gases because of intermolecular distance. Intermolecular distance is very more in the case of gases, so for that inter-attraction forces are less. Intermolecular distance is moderate in the case of liquids, so inter-attraction forces also less. Where in the case of solids, intermolecular distance is very less, so for that inter-attraction forces are more. Because of the highest interaction forces, the rate of diffusion is less in the case of solids. From this, clearly we can understand the concept of diffusion and as well as the experiment to prove the topic of the diffusion. Thank you.